Hello and welcome to a short video on repetition algorithms. In an algorithm, repetition gives us the ability to perform the same tasks over and over. For example, add more milk to my coffee until I'm happy with the colour of the drink. Or, while the traffic light is green, keep driving. Now, when we look at these two actions, the decision is reached using different methods. In my first example, I add more milk to my coffee until I'm happy with the colour of the drink. This means that after adding boiling water to my coffee cup, I add milk before I check the colour of the drink. Or, to phrase it another way, I check the situation, my coffee colour, after I perform the action, add milk. This is called a post-test loop. In the other example, while the light is green, I can keep driving. This means that I check the situation before I perform the action, because I check the lights before I change or modify my driving. This is called a pre-test loop. Today we are going to learn about both post and pre-test loops. Woo! So let's start with a flowchart. Remember that a flowchart only has 3 symbols. The terminator symbol is a rounded rectangle. It appears at the top and the bottom of every flowchart. Remember that at the top of the algorithm we write the word begin, and at the end of the algorithm we write the word end. The process symbol is a rectangle. We can put a step or task in this symbol, but we need a separate symbol for each step or task that we do. Finally, the decision diamond allows us to add any question to the flowchart. Let's try to create our first repetition algorithm. Our first algorithm for selection is about making a cup of coffee. I add more milk to my coffee until I'm happy with the colour of the drink. Let's start with the terminator symbol. If we were doing this properly, we would need to get a cup, add water to the kettle, get a spoon, get the coffee out of the cupboard. You get the drift. When writing an algorithm, we can show that there are steps we are leaving out by using the 3 dots, called an ellipse. Our next step is to boil the water. Since this is not a question, we add it to a process rectangle. Next, we add coffee to the cup and water to the cup. Notice once again that we have used process rectangles for these steps. Now it's time to add milk. Our scenario says that we need to add more milk. This means that we add milk first and then check if it is enough. Add milk goes into a process rectangle, and then as we are asking a question, we need the question diamond. Notice that we have a question mark at the end of our question here. Now, because we can only have 2 responses to this question, we can make our lines come from the sides of our diamond, and we need to make sure we label one of these yes and the other one no. What will we do if we answer yes? We need to add milk to the cup again. Rather than adding another process that is just a repeat of this process here, we can actually send our flowchart back to just before this process. By doing this, what we actually find is that we can add milk repeatedly without having to add another process in our flowchart. However, if the answer is no, we don't need to do anything. To end our flowchart, we add an end terminator. Done. Now that we've created a flowchart, let's design a post-test repetition algorithm in pseudocode. To help you with remembering your pseudocode keywords, I'll put them in capital letters. We start pseudocode with the keyword begin. Most of our keywords in pseudocode appear in pairs, so we try to indent between keywords so that we can check we have paired them correctly. Like in the flowchart, we are once again going to use the ellipse to indicate missing steps. Any steps that we have in our flowchart here can then convert to steps in pseudocode. So, we're now up to putting in our loop. The loop is checked after we have added the milk. So, it's a post-test loop. The keywords for a post-test loop in pseudocode are repeat and until. Let's start filling in our steps. What question are we asking for this decision? The question's going to go here, in our condition area. We need to add the action, or what we're going to do in our loop. In this case, we're adding milk to the cup, and that's going to go into there. Now we can finish the pseudocode by adding the end key term. Now when we look at our pseudocode, we can check quickly that there is a matching pair of begin and end. And there is also a repeat with an until. And we can do all this really easily by looking at our indents. When we look at our post-test loops, what is the minimum number of times that we can perform the repeated task? Well, when I talk about the repeated task, I'm talking about adding milk to the cup. You'll notice that as we travel down here, we always do this at least once. We can see that we enter this loop and perform the repeated task at least once. That's why it's called an unguarded loop. Now, let's try to create an algorithm for a pre-test or guarded loop. While the light is green, I can continue driving. We always start our algorithm with a terminator called begin. If we were doing this properly, we would need to check what colour the light is and compare it to all of the available results. We'll use an ellipse here for speed. We now need to check if the light is green. Because we are asking a question, we need to use a question diamond. If the light is green, we keep driving and check the light again in a little bit of time. So we'll add a process. If the light is not green, we should stop. We can now end the algorithm. Done. Let's try to convert this into pseudocode. We'll start with the keyword begin. Add an ellipse from the flowchart. Now we need to add our pre-test loop. This repetition uses the following keywords: while and end while. Our condition here is the question we asked in our flowchart. Is the light green? Let's fill that in. If the light is green, our action is to keep driving. We now need to add in our other process. And finish off the algorithm. Congratulations! You have just now learnt the 2 methods of repetition available in algorithms.